Okay, now I'll show you how to train RF-DETR instance segmentation models. There will be 4 main steps: installation guide, dataset preparation, training, and inference part. And here's one example. You see the segmentation follows. So this will be a short video, and I will share link to this article in the comment section. You can read it. And if you start with installation part, first you need to create a conda environment, then you need to install PyTorch with GPU support. For these 2 steps, I have a separate article. You can directly follow this. This will took about 20 minutes, so you can directly follow this. And after that, you can check if everything is okay by these 2 lines. Let me copy this. So I created the fresh notebook here, and you see my environment here. I already created it, RF-DETR stake. You can name it whatever you want. It doesn't change anything. Yeah, you see this, it says true, CUDA is available, and here is the PyTorch version. So this can be different on your local, it doesn't matter. And after that, you need to clone this RF-DETR repository. Let me show you this. Yeah, you see, there's one example, I think. Yeah, you see the segmentation, perfect. And there's some metrics, and there's some pre-trained models. I will explain this later. So after that, you need to install supervision, and there's few more things. And of course, you have to install some dependencies from this RF-DETR repository. I already did that. You see this repository here. So let me continue. Yeah, after you installed everything, you can copy this cell, and you can check if everything is working. Yeah, you see using device CUDA again, and here, yes. So it will automatically will download the pre-trained model here on first run, and here you see pre-trained weights at blah blah .pt, perfect. So yeah, the next step is dataset part. There's only one golden rule, and your dataset must be in CocoJSON format. If it is not, you have to convert your dataset format to CocoJSON format. For example, I choose this balloon dataset from internet, and its format is not CocoJSON. It's something like VGG image annotator format. So I converted it. You can use ChatGPT for that. This code is only for this VGG format to CocoJSON format. This will not work for you on your first specific dataset. But most of the datasets are internet in CocoJSON format. So maybe if you find CocoJSON format, you can directly follow this. But if it's not, you just need to write few lines. So let me show you this dataset. Here I converted to CocoJSON. Let me show you. These are images for both train and validation folders, and there's one JSON file for train and one for validation. And format is clear. You see there's like file names, IDs for each image, and you see, for example, these are the mask coordinates, one by one. And for example, for this image, this is one mask. Of course, there can be multiple masks in one image. So the same for validation as well. And let me continue. Yeah, the training part is not that complex. There's just few lines. Let me copy this. But there's just few important things. I'll explain this now. Yeah, here you see this is the pre-trained model. I choose Nano because my GPU is not that powerful. So I stick with this Nano model. You see here, this is the smallest one. But if you have powerful GPUs, you can go with this large model or even 2x large. So it all depends on your purpose. Depends on your dataset. So you can choose any of these models. For example, if you want a large model, you just have to change this to large. That's it. Of course, you need to import this as well. So you have to move your model to GPU, and after that, this is directed to the dataset. You see here my dataset, and here you can change this epoch number. It's up to you. And batch size is important. If you got memory errors, you can reduce this value to 1, even 1. But if you have powerful GPUs, you can set this to 4, 8, 16, 32. It's up to you. And for resolution, it has to be divisible by, I think, 12. And let me check from article. Yes, it's to 12. And you can increase this, reduce this. Yeah, it's up to you again. And this is output directory. You can change this as well. So I already trained my model, and I will show you in this notebook. So depending on your GPU, this might take a lot of time, or I don't know. It all depends on your dataset and GPU, and of course these parameters. So you see the training here. Okay, after training is finished, okay, you see the model files here, and for example, matrix. You can use this for visualization. Yeah, you see there are some like epoch number, error values, but let me check. Yeah, lost box. You see there has to be some MAP values as well. Yes, you see here. You probably want to visualize these ones, but it's up to you again. And you can use any of these models, but you can directly use best total, and it's up to you. Or you can use this one. So the inference part is quite simple. You can copy this. And here, actually, let's run this. So here we are basically loading the model. checkpoint base total. And after that, yeah, this is checkpoint path, and we are loading the model, and you can change this image. Here is the inference part. You can change this threshold and class names. We have one class, I think, but let me check later. Okay, I will check after this cell run. And here we are directly using this mask annotator and label annotator for visualization. And you can display it with matplotlib or OpenCV as well. It's up to you. Okay. Yeah, okay, you see the result. There are balloons, they are segmented. And let me show you this. Yes, we have one class. Depending on your dataset, this can be 10,000, anything. So let me show you a few more examples. Yeah, you see balloons are segmented. So I think that's it for this video. Thanks for watching. See you soon.